Right, we're looking at covalent compounds. Covalent compounds are formed when a metal reacts with a non-metal. So let's write that down there. So rather than giving up or accepting electrons, they share electrons, okay? So let's write that down then. A covalent bond is when atoms share, and that's the key thing. They share. They don't give anything up. They share electrons. Let's just say share electrons. Let's just keep it simple. Right. So what I'm gonna do is I'm gonna do, what's a good one? Ammonia. Right. Remember what we said ammonia is? Ammonia is a covalent molecule. Right. Ammonia. Let's do a different letter. Left of sun, not different color. There. Ammonium is a cation. It's a positive ion, so it has NH4 plus, whilst this one is NH3 and there's no charge. It's good to know the difference between those two because it comes up a lot and it causes a lot of confusion. Right, and the reason they share is, let's write this down. So each, is that how you spell each? Right, okay, let's write this way then. Each, so each atom has a full outer shell. Okay, so let's try to draw, for example, I don't know, water. We need to draw water. Right, let me draw one actually. Let me draw an oxygen. There's oxygen. There's the nucleus. So let's try to get this such that that's the nucleus. I'm not interested in what's inside it. All I know is that it's got 8 electrons. So I'm going to do first shell. We're only allowed how many? 2. 1, 2. It doesn't matter if I do a dot or a cross. So where are we? There we are. So now what we're going to do is 1, 2. I'm just going to draw it this way because it's easier to then add and take away. So we've got 2, 4, 6. We need 8, 7, 8 electrons. Why do we need 8? Let's have a look. So if I did O and I looked at the relative atomic mass is 16 and the atomic number or proton number, we'll call it atomic number, is 8 because we're doing chemistry. So I've got now, let me get this, look, 1, 2, 3, 4, 5, 6, 7, 8. I'm happy with that. Now let me draw hydrogen in the same way. I'm going through this slowly. So you've got hydrogen. I'm going to give it a color so then we can differentiate. And let's draw the first electron shell. And we know that it's got one electron. I'll just put it there for argument's sake. But so that's hydrogen. Yeah, we've got one and one. Right. With water, you know that water is H2O. So let me get the mouse. So you've got two hydrogens and one oxygen. So we've got one oxygen here. We need another hydrogen. So all I'm going to simply do is let's just group that for now, and let's just copy that and paste it. There you go. So we've got two. What I'm going to do with this, I'm going to group it and I'm going to move it over here. Right. This hydrogen is going to join up here. And I'll explain what's going on in a second there. And this one joins up here. But this electron is going to pair up here. So if you look now, let me just change the color on that. Change the color on that. So then you can see it. So the hydrogen's electron shell has now got two electrons. It's happy because it's shared one of its own and it's borrowed one from, and it's sharing one from the oxygen. So now it's happy because the first shell has got two. Same thing here. Now if you look at, let's look at this here. What color should we use? Is there a nice color? That nice color? Not really, no. Right, you. Okay, we'll have to live with that. Now you've got 1, 2, 3, 4, 5, 6, this dot, 7 and 8. Because this oxygen now has got a full outer shell. It's got 8 electrons. So it's happy. It's trying to become full so it's more stable. So now we've got a water molecule where they've paired them up. Now watch this carefully. They do not like, let me draw it here. They do not like, that's the electron shell and that's the electron shell. They don't like them like this. They don't want you to show them like this as a dot and cross. What they want to see is that's the hydrogen, just say, and that is the oxygen. Can you see the overlapping? So they want to see the dot and the cross inside this area here. Okay, I'm just highlighting it by shading it. You don't have to shade it. Let's get rid of that. So that's what they want to see. So we need to rejig this. Yeah, so when we draw it, we don't want to draw it like that. So just give me a second. Right. So if you look here, the dot and the cross, the two electrons are inside this overlap like here. Okay, so that's what they like to see. Or what you could do is you could draw it without the electron shells showing. So normally they just want the outer electron shell. So for example, let me give you this. If I said to you, let's delete that, and let's delete that, let's delete that, and let's delete that. You could do that. They would not want the inner electrons because it's just going to cause confusion. You could leave it like that. Right, you could leave it like that, but it's normally visually more pleasing and easier to see. You can make more sense of it when you've got the shells on. Right, okay. Right, they will expect you to do simple covalent compounds. Right, here are some. So see if you can draw these. And what I'll do is I'll put up some diagrams for them. So hydrogen diatomic molecule, chlorine, diatomic molecule. Right, you've got oxygen, diatomic molecule. So what am I saying when I'm saying diatomic? Diatomic. It just means that they run around in pairs or twos, yeah? So can you see this, the mouse there, that two? They run around in pairs. Right, you've got hydrogen chloride. You've got, we've done water. You've got methane, okay. We've not covered that yet, methane. That's the gas that comes out of your cooker. Right, we need to draw these, so you crack on, maybe try drawing some. Right, these are the ones then that you need to know. There's no nice color, is there, that we can use? Right, okay, so this here, the first one is oxygen, and have you noticed this has got a double covalent bond, so there's 4 electrons that are shared, 2 pairs. You've got hydrogen, chlorine, oxygen, so we've done those. You've got hydrogen chloride, and you've got methane here. Yeah, so let me write those names down. This is methane, you'll need to know that. This is hydrogen chloride, hydrogen chloride, don't mix it with hydrochloric acid, although it's similar. This is hydrogen gas, it's a diatomic molecule. This is chlorine gas, it's a diatomic molecule. This is oxygen, it's a diatomic molecule. These are all covalent bonds. Right, should we write a good definition for, where are we? There we are. Right, a covalent bond is when 2 or more atoms, we'll just put for when 2 atoms share electrons to get a full, let's write that properly, full outer shell. Right, now that you've got that, why do they have high melting and boiling points? Because you have strong electrostatic forces of attraction. I'll explain that, what that means. Yeah, between, I like to split it up so then I know I've got all the parts. So strong electrostatic force of attraction between shared pair of electrons, and so you can say negatively shared pair of electrons, and both positively charged nuclei. Not nucleus, but nucleuses. We don't say nucleuses, we say nuclei. Nuclei. Right, we need to finish that off. That needs lots of heat energy or thermal energy to break or overcome. So this here, that's the reason. So the question you can ask yourself, why do covalent, let's write let's be more specific with this. So then you just end up learning one day. Why do giant covalent compounds have high melting and boiling points? That's the question, yeah. Because there's strong electrostatic force of attraction between shared pairs of electrons, or a shared pair of electrons, and both nuclei. That needs lots of thermal energy. That needs lots of thermal energy to break. Just leave it like that. What do they mean by strong electrostatic forces? So I know a nucleus here is positively charged. I know an electron is negatively charged. Because they're oppositely charged, these two have an attraction. They attract each other. And that is the electrostatic force of attraction. Right, that's it. That was a long one. Right, but we've got to get through it.